Here we have an example of converting both directions between degrees to radians and then radians to degrees. So this is a very good example. I like this one because it makes us think both ways. So we have degrees and radians are two different systems, degrees and radians, for measuring an angle opening, aren't they? So what is an angle first off? So an angle, I think you know, is an opening between two line segments. So if that's a doorway, a door partway open, right? We'd say how far open is that door? What's the angle there? So that's what an angle is. So if this is the hinge of the door, you know, and this is the doorway and it's open. So an angle, now we have two systems for measuring the opening of an angle, degrees and radians. So it's just like Celsius and Fahrenheit. Those are two systems for measuring temperature. So what's the connection? 180 degrees is equal to pi radians. That's the connection between the two worlds, the two systems. So we use that as a fraction to convert units. Here we go. 230 degrees to radians. So I'm going to take 230 degrees. And what you do is you put it over 1. This is how you convert units. I learned this in chemistry, actually, not a math course, but chemistry. To convert units, you put it over 1, and then you multiply by another fraction. And the fraction is going to be these guys, always. But the question is, how do you know which one goes on the top or the bottom? Is it the 180 on the top, pi on the bottom, and vice versa? Well, it depends. It's going to be different for these two examples. Here's the key. Hear this if you hear nothing else. Well, I'm not saying that very well. Don't hear that. Make units cancel by putting whatever you start with in the denominator of the next fraction. So what am I talking about? So I'm starting here with degrees, right? So that means I'm going to put degrees in the denominator of the next fraction. 180 degrees. Why? Because I want degrees to cancel. That's the key thought. Make units cancel. Units cross-cancel just like numbers do. That's what was surprising to me when I took chemistry. I'm like, oh, units can cross-cancel just like numbers. So that's how you know which way to put it. You put in the bottom whatever you started with, because that way it'll cross-cancel, because we're trying to get out of degrees. We want them to go away, and we're trying to get into radians. So then you put the pi radians in the top. Do you see that? So now, after you've done that, see how these will cancel. No more degrees, bye-bye degrees, but radians are left. Perfect, that's what we want. We want radians. So now just go straight across the top, straight across the bottom. We have 230 pi over 180. 230 pi over 180. And then divide by 10, top and bottom. And we get 23 pi over 18 radians. No more degrees. Those cross-canceled. Good. Let's try the next one. Now it's going to be the other way, because we're starting at, let me rewrite that for you. We're starting with 10 pi over 9. Now, that 10 pi over 9, is that radians or degrees? Well, if you don't see a degree symbol, which we don't, it just says 10 pi over 9, it's automatically radians. If there's no degree symbol, then it's automatically radians. Radians don't need a symbol. They don't even need the word radians. I'm just adding that in for extra clarity. But if you just write 10 pi over 9 and you don't write any symbols, that means radians by default. Radians are the default. They're the automatic if no units are written. If you want degrees, you got to write a degree symbol. But the automatic, if there's no units written, is radians. So that's 10 pi over 9 radians, and they want me to change it to degrees. Well, how am I going to do it? Well, here's the rule. Remember the rule over here. Make the units cancel. So you start by putting whatever you start with in the denominator of the next fraction. What did I start with? Radians. So put radians down here in the denominator of the next fraction, so that radians will go bye-bye, right? Whoop, sorry about that. I want to get out of radians. what's the connection? It's always these two is always the connection. Pi radians is 180 degrees. See that? See how I know? It's upside down of what we did here, isn't it? It's the other way. It's different. Do you see that? Right? Why? Because I want radians to cancel this time. Over here I wanted degrees to cancel, so I put degrees in the bottom. I put the 180 degrees in the bottom. Here I want radians, because I started with radians, I want radians to cancel, so I put the pi radians in the bottom. It's always pi on one side, pi radians, and 180 degrees on the other side. It's just how do you know which way? Well, you got to get units to cancel. So, all right, so what's left then? Just go straight across the top. So 10 times pi times 180 degrees over 9 times pi, right, the bottom. So just straight across the top, straight across the bottom. Pi's cancel, don't they? So let's bring it down here. So it's 10 times 180 degrees over 9. Oops, that 9 wasn't the best. Okay, and that's multiply on the top. That's 1800 degrees over 9, just 10 times 180. Right, and then 9 divided by 18, 2 times, that's 200 degrees. There's the answer. 200 degrees. So we converted from radians to degrees, and before that we converted from degrees to radians. And we always use the pi radians is 180 degrees bridge between the two worlds, and you know which way to put that fraction. Whatever you start with, you got to put in the bottom to get that to cancel, to get out of that system into the other system. There we go.